So I wanted to try to give you a quick sum up of the limits approaching infinity, also known as end behavior, because there is a nice shortcut to those. So I just want to discuss it first, and um, we'll visit this in a coming unit. So um, I kind of think it's important that we make sure that we're pretty good with it. It's something that, like I said, there are shortcuts. You can do it sort of on site. You can find the end behavior just by looking at the function. So just to talk briefly about end behavior, if I'm looking as x approaches positive infinity, it's looking at the right end behavior, what's happening on the right end of the function, and there are three things that can happen. It can rise to positive infinity, and so I would, as I'm following the function to the right, what's happening? It's rising infinitely, or it could drop to negative infinity, or it maybe settles out towards some constant, some number. This one appears to be approaching maybe zero. If I'm looking at end behavior as x approaches negative infinity, that's the left-hand side end behavior. Again, the same thing can happen. I can rise to positive infinity as I follow the function to the left. Negative infinity, it could rise to positive infinity. As I follow the function to the left, it could drop to negative infinity. And sometimes that rise and drop are a little bit subtle. But if it looks like it's rising, even very slowly, that means it's rising to positive infinity. If it looks like it's dropping even very slowly and then it's dropping to negative infinity, or again, just like it could on positive infinity, it can sort of level out. So where this one appears to be approaching some positive value, and if I had put a scale on this axis here, maybe, 1, 2, maybe I would say this appears that it's approaching positive 2. Okay? So let's start by discussing what we're actually doing when we're looking at end behavior, because infinity is so enormous that it takes over pretty much the lead term of the function. And so if I'm going to try and look for end behavior, and if I want to try and find it quickly, what I need to do is go through these steps. I isolate the lead terms, or the highest power in the numerator and the denominator, and then I rewrite it as a fraction and reduce that fraction. And then if necessary, and I say if necessary because I'm going to be showing you some shortcuts or things to look at, we're going to see some patterns. But if necessary, plug in some values. And when I say plug in some values, if I'm going to positive infinity, plug in numbers that are getting bigger. I don't get real creative. I plug in 100, 1,000, 10,000. If I still can't find the pattern, then I'll plug in 1,000,000. And then I look for patterns. If it's negative infinity, it's negative 100, negative 1,000, and look for the pattern. And I find out what appears to be happening. So let's just start going through that procedure for the three problems that are on the bottom of this page here. So again, my first step is to isolate the lead terms, the highest power. So in this case, the highest power on top is just x. It doesn't even matter that there's a -1 here, because think about it, as x is getting super enormous, very, very large, it's like pennies on billions of dollars. They don't really mean that much, okay, compared to an infinite amount. So that's why these end things, even if I was adding 100 or subtracting 100, 100 is still nothing compared to infinity. Infinity is so mind-bogglingly large that we, as somebody could say, I think 1,000,000 is the biggest number we can get, and somebody can say, well, 1,000,001. Well, then 1,000,000,000, 1,000,001,000, and it just goes forever and ever. And those numbers are not, they're so huge, we can't even get there. Okay. So I'm down to my lead terms here. So I'm going to rewrite that as a fraction, x over x squared. I'll reduce that. That becomes 1 over x. And now I'm going to start to plug in values as I approach infinity. So I just make a little table. So I'm going to do, here I'll plug in values for x. I'll just make this little table here. I'm going to plug in 100. I'm going to plug in 1,000. I'm going to plug in 10,000. into 1 over x and see what I get and see if I can see what's happening. Well, 1 divided by 100 is 0.01. 1 divided by 1,000 is 0.001. 1 divided by 10,000 is 0.0001. And if I were to continue doing this, getting bigger and bigger and bigger, adding a zero, 100,000, a million, 100 million, a trillion, I'm going to keep adding zeros before the 1, after the decimal, before the 1, which means that this appears to be approaching 0. So my limit here is 0. That's my limit. This appears to be approaching 0, so my limit is 0. Now when I look at a problem like number 2, and I said, take a look at the numerator and the denominator and isolate the lead term. Well, in this problem, the denominator is just 1. In every value, you can have a denominator of 1 if there's no denominator there. So when I rewrite my fraction, I'll have x squared over 1. That's my lead term on the top and on the bottom, x squared over 1. Well, when I make my table again, I'm going to be looking at just x squared. And in this case, it's approaching negative infinity. So I'm going to plug in negative numbers, negative 100, negative 1,000, negative 10,000. And I'm going to be squaring these big numbers. So negative 100 times negative 100 is 10,000. Positive, because when you square negative, it becomes positive. Negative 1,000 times negative 1,000 is 1 million. I don't even think I need to finish this, but I can. Negative 10,000 times negative 10,000 is a 1 with 1, 2, 3, 4, 8 zeros after it. So there we go. 100 million. So this definitely appears to be rising, and as I continue to plug more, it looks to me like I'm getting bigger and bigger and bigger. So I say my limit here is approaching positive infinity. I didn't mean to put that in there. Okay, so positive infinity for that one. So I approached 0, I approached positive infinity. Okay, so now let's see what else can happen. Again, I'm going to look at my lead terms. So here I'll isolate the highest. I'll reduce it. The limit as, I don't even want to write that. This is 2x over x, or just 2. So I'm going to plug in, this is approaching positive infinity, 100, 1,000, 10,000. And I'm plugging it into 2. Well, wait a second. I have nothing to plug in. This is just a constant. So if x is 100, the function is always a constant 2. 1,000, 2. 10,000, 2. A million, it's going to be 2. What is this approaching? 2. So my limit here is 2. So what I ended up here is with 2 values and 1 that approached infinity. And so these 3 different results, I know it's 2 values and 1 that approaches infinity, these are the 3 types of results that we're going to get. We have only these patterns. Is it going to only have a variable on the bottom when I reduce it down? I call that bottom heavy. Then it's going to approach 0. Does it only have a numerator when I reduce it down? I call that top heavy. Then it's going to approach positive or negative infinity. And you have to be a little bit careful about this because it depends on what you're approaching. Am I approaching positive infinity or am I approaching negative infinity? And it also depends on what you're left with. Are you squaring it? Are you cubing it? Is it x by itself? Because odd powers are going to be true to their sign, meaning if there is an odd power left, then, and I plug in negative infinity, it will remain negative. If it's an even power left and I plug in negative infinity, it will become positive. If it's positive infinity, it's not going to matter. It's just going to approach positive infinity. So the negative infinity one is the one that you're going to have to watch out for. Am I plugging in negative infinity? What is the power that's left? An even power or an odd power? That'll determine the sign. So that's one that you have to be a little bit careful of. Okay, and then the last result here is, I call this neutral. Is it neutral, meaning I have the same power of x in the numerator and the denominator, which leaves me with just a constant. And then I end up with a limit that is just this constant. It's a constant other than 0. So we have a 0, we have infinities, and we have constants other than 0, or a non-zero number. So let's sum that up. I'll do my shortcuts here. So I have top heavy means that I have x left on top only. I was trying to figure out how to say that smoothly. I guess I don't know. And then we are going to approach positive or negative infinity will be our solution. If it's bottom heavy, where it's x left on the bottom, only, what am I spelling? Okay, that's going to approach 0, because the bottom heavy, it'll be 1 or a number over some very big number, and when you fraction or divide it out, it'll approach 0. And then neutral, and I always spell neutral wrong, so I don't know. If I did, please laugh at me behind my back, not to my face. Neutral is when you cancel out all the x's. Cancel. I'm worried about spelling neutral wrong, and I can't even spell cancel. Cancel out all of the x's on the top and the bottom. And then we'll approach some constant. So I don't even need to take that time to make that table. I can just look at the function. Is it top heavy? Is it bottom heavy? Is it neutral? Now, I do want to point out when I talk about top heavy and bottom heavy, it's on the x's only. That's what I'm looking for. Don't worry about the number in front, because there's, in this one, 2 in front of the x does not make this bottom heavy. It's the power on x that makes it the heaviest. Okay, so when I look at this problem, I'm going to go down to the lead terms. Gotta change my color here. Go down to the lead terms, rewrite it. This is x squared over 2x. One of the x's will cancel out, so I'm down to x over 2. I call this top heavy. There's a 2 on the bottom, I get it, but x is the one that's going to take control. X is the only part that's going to change. This is top heavy. Because this is top heavy, it's going to approach an infinity. And the infinity it approaches depends on what I'm looking at here. And it says I am approaching positive infinity, so I'm putting in very large numbers on the top and dividing them by 2. I think of it as, what do I get if I put an enormous number and divide it by 2? I'm still going to end up with a very enormous positive number. So my solution there is positive infinity. Top heavy. If this were approaching negative infinity, this, and I put it in here because it's not squared, it's to the first power, this would approach negative infinity. That's, again, that's the only one that you really have to watch out for when you do those. Okay, so then I'll go here. Here's my problem. I isolate it. I do x squared over x squared. I reduce it. This reduces down to 1. Therefore, my limit is 1. Let's do our next one. Isolate. This is a little bit bad, and I'm going to off to the side show you an example of something, but this is just kind of gives you a real quick sort of reference to look at. The lead terms are not always the front terms. The lead terms are the highest power. And again, in a little bit, I'll show you what I mean by that, or how we can approach that. But this is negative x over x squared, which leaves me with negative 1 over x. I'm plugging in really big numbers. Positive infinity. This negative, it's negative 1 divided by a really large number, which is going to end up with 0. It doesn't matter that that one's negative, because 0 is neutral. It's neither positive nor negative. Okay. Let's try our next ones. I think you probably get the gist of this. Here I am, x to the 4th over 4x squared. reduces down to x squared over 4. I'm plugging in negative infinity. That's negative infinity squared divided by 4. Really enormous, large negative number squared makes it positive. Even if I divide it by 4, it's still very positive. Positive infinity. Lead terms, 10x divided by x cubed reduces down to 10 over x squared. That's bottom heavy. That means I'm going to put very large numbers in the bottom. I'm approaching negative infinity. It doesn't even matter what I'm approaching, if it's positive or negative infinity, because it's just going to get really large, and therefore I'm going to end up with a bottom heavy 0 limit. And then for the last example that's written here, but again, remember, I'm just going to go over one more of those two with you just to make a point. And this is lead terms 2x squared over 5x squared reduces down to 2/5. Therefore, that constant hold on to the paper, 2/5, pretend that says 2/5, is my limit. Okay. Now, I want to make one sort of obnoxious point before I let you go on your own. And that one sort of obnoxious point is that if my limit as x approaches, I'll just do negative infinity just for kicks here. If I am looking for my lead term, let's say I have 17x to the 18th power minus 25x to the 100th power plus 32x to the 50th power. Again, I'm being super duper, obviously very obnoxious. This says 25 over 45 plus 13x to the 97th minus, let's go with 18x to the 5th plus 25x to the 96th. Okay, there we go. All right, again, I'm being super obnoxious, and when we're looking for the lead terms, we're looking for the highest power. The highest power on top is 100, highest power on the bottom is 97, so I'm going to do negative 25x to the 100th over 13x to the 97th. I can cancel out 97 x's off the top and off the bottom, so this is negative 25x cubed over 13. Really, all I care about is this power here. When I'm putting in my infinity, I'm going to plug in negative infinity. I'm going to take negative infinity to the third power, which would make this an incredibly large negative number. And then I will have to multiply it by a negative number. So I have a negative times a negative, which is positive, divided by a positive, and therefore I'm approaching positive infinity. So again, don't always think that the fronts are going to be your lead terms, and talk yourself through it when it comes to the infinity. Make sure that you take the sign in front of it, that negative 25 comes in front of there. That's going to affect your final. Again, this is going to be a negative times a negative divided by a positive, which leaves me with a positive infinity. So again, I hope that kind of helps a little bit if you needed it. Maybe some of you found this section okay. Quiz tomorrow, and as always, I really hope you guys have a good day. Let me know if you need anything.